A startling revelation made by the James Webb Space Telescope has unveiled what seems to be city lights in deep space, positioned roughly 7 trillion miles away from Earth. This groundbreaking find has reignited debate and sparked heightened curiosity about the potential existence of extraterrestrial life. The telescope focused its observation on Proxima Centauri b, the closest exoplanet to our planet, and noticed unusually bright lights emanating from its surface. What could these city-like illuminations on Proxima Centauri b signify? Could this be a clue suggesting the presence of life beyond Earth? Join us as we delve into how the James Webb Space Telescope identified these unprecedented phenomena in space. The discovery of city lights in deep space. For years, scientists and the public have eagerly anticipated discovering signs of life beyond our solar system. Any evidence supporting this idea has been met with great enthusiasm. Recently, the scientific community was stunned when compelling indications of life in space were detected by the James Webb Space Telescope. While exploring the cosmos and transmitting data back to Earth, the telescope observed curious city lights flickering from the exoplanet Proxima Centauri b. As their name implies, these lights resemble the glow of a distant city, leading to speculation about the presence of an alien metropolis on the exoplanet. This discovery has left researchers in awe, as it could indicate the existence of civilizations unknown to humanity in the vast expanse of space, and we are only beginning to uncover them. Infrared emissions and their significance. The discovery of these city-like lights, located 7 trillion miles from Earth, has captured the imagination of both the scientific community and the public. NASA engineers are now wondering just how long these lights have been shining, waiting for humanity to develop the necessary technology to detect them. David Kipping, a space expert from Columbia University, finds the star system that houses Proxima Centauri b to be particularly intriguing. He explains that this system, which is the closest to our own, shows unusual warming patterns that differ from other planets. Unlike typical rocky planets, which absorb sunlight and emit infrared radiation, Proxima Centauri b's infrared emissions are markedly different from those of its host star, Proxima Centauri. This distinction offers a clue to a significant observation made by the James Webb Space Telescope, which is adept at detecting infrared frequencies. The distinct heat signature of Proxima Centauri b is expected to play a pivotal role in uncovering the planet's atmospheric secrets. Researchers are now utilizing the latest advancements in infrared imaging to study the exoplanet's atmosphere in greater detail and explore the possibility of life on this distant world. Thanks to its unparalleled infrared sensitivity, the James Webb Space Telescope can explore the nighttime side of Proxima Centauri b, capturing even the faintest beams of light in the immense darkness. This is typically a challenge for space telescopes, but the Webb telescope is perfectly suited to detect even the smallest light emissions from distant objects, making it the ideal tool to confirm whether the rumors of city lights on the night side of Proxima Centauri b are true. Any artificial light in the universe can be detected by the telescope as long as it falls within a frequency band 1,000 times smaller than starlight. The unique relationship between Proxima Centauri b and its star. Proxima Centauri b's unique relationship with its star and surface features is also worth noting. The daytime side of the planet is home to numerous solar panels that capture energy from its star, while its spectral edge reflects incoming light, contributing to its energy balance. As Proxima Centauri b orbits its host star, Proxima Centauri, it experiences both day and night periods, much like Earth. During the day, the planet is exposed to intense solar radiation, while at night, it cools down. Known for its fluctuating temperatures, the degree of this variation depends on the planet's composition. If Proxima Centauri b lacks a significant atmosphere, the temperature differences between day and night would be extreme, with scorching heat during the day and freezing cold at night. Determining the extent of these temperature fluctuations is crucial for astronomers seeking to understand the planet's atmospheric composition. Thanks to the advanced infrared imaging capabilities of the James Webb Space Telescope, researchers are able to efficiently analyze the planet's thermal emissions, gaining valuable insights into its atmospheric properties. Searching for life on Proxima Centauri b. Interestingly, the Webb telescope's orbit around Earth coincides with Proxima Centauri b's orbital period, allowing scientists to observe the planet's day and night cycles within just 11.2 Earth days. Since Proxima Centauri b is believed to possess an atmosphere, the next step is to analyze its chemical makeup to determine whether it can support life. Gases such as oxygen, water vapor, and methane are key indicators of life. If these elements are present, they could suggest conditions conducive to life. However, determining these atmospheric components requires a careful analysis of light passing through the planet's atmosphere, a task that remains challenging even with the extraordinary capabilities of the Webb telescope. Future telescopes and the search for extraterrestrial life. Though the Webb telescope is capable of studying only a limited number of nearby habitable worlds, astronomers are looking ahead to future ground-based observatories, such as the Extremely Large Telescope, ELT, which is scheduled to begin operations in 2028. The ELT will focus on the atmospheric characteristics of distant exoplanets, providing crucial data to assess their habitability. NASA researchers and the public eagerly await the launch of future space telescopes to complement the Webb's ongoing work. Until then, the James Webb Space Telescope remains an essential tool in our quest to uncover the secrets of far-off exoplanets. Despite its current limitations, the Webb telescope holds tremendous potential to revolutionize our understanding of exoplanet exploration. Conclusion. The ongoing investigation into city lights on Proxima Centauri b, located 7 trillion miles from Earth, has captivated the academic world and sparked renewed interest in the possibility of extraterrestrial life. This discovery highlights the immense capabilities of the James Webb Space Telescope and marks a significant milestone in our quest to understand the universe. While it is still too early to definitively confirm that the lights observed are indeed artificial, the very possibility has opened up a new frontier for research. If these lights are indeed a sign of intelligent alien life, the implications for science, philosophy, and our place in the universe would be profound. The James Webb Space Telescope's role in this discovery is vital. Its unprecedented sensitivity to infrared light and its ability to capture faint emissions from distant objects make it the ideal instrument to explore the deepest mysteries of space. Without such advanced technology, many of the phenomena we are now observing would remain hidden, their existence only a distant dream. In addition to its observations of Proxima Centauri b, the James Webb Space Telescope is also shedding light on a host of other distant exoplanets. Researchers are now using the telescope's advanced capabilities to study exoplanet atmospheres in the hope of identifying signs of life. As technology advances and our understanding of the universe deepens, we are poised to make even more groundbreaking discoveries. The James Webb Space Telescope, with its incredible capabilities, will continue to lead the way in this journey of exploration. The next step in the search for alien life. As the James Webb Space Telescope continued its observations, scientists at NASA and other space agencies around the world scrambled to analyze the data. The unusual brightness on the surface of Proxima Centauri b remained a mystery. Was it truly artificial, the result of some advanced extraterrestrial civilization, or was there a natural phenomenon at play? To answer this question, astronomers turned to other telescopes, including the Hubble Space Telescope and ground-based observatories equipped with advanced spectrographs. The goal was to study the wavelengths of light emitted from the planet and determine whether they matched known artificial sources, such as LED or fluorescent lighting. Meanwhile, the SETI Institute ramped up its efforts, pointing its radio telescopes toward Proxima Centauri b in the hopes of detecting any radio signals that might indicate intelligent communication. Days turned into weeks, and then months, as researchers combed through the vast amounts of data being transmitted back to Earth. A breakthrough in the data. Then, in a stunning turn of events, an anomaly appeared in the spectral analysis of Proxima Centauri b's atmosphere. The James Webb Space Telescope detected traces of gases that are rarely found in natural environments, compounds such as nitrogen dioxide and chlorofluorocarbons, CFCs, which, on Earth, are primarily the result of industrial activity. This discovery sent shockwaves through the scientific community. Could this be the first true evidence of an alien civilization? While these gases could theoretically be produced through unusual geological activity, their presence in such quantities strongly suggested an artificial origin. To confirm their findings, NASA collaborated with the European Space Agency, ESA, and China's National Space Administration, CNSA, to launch a series of follow-up missions. The most ambitious of these was Project Horizon, an initiative to send an advanced probe to the Proxima Centauri system. Preparing for the first interstellar probe. Unlike previous deep space missions, Project Horizon aimed to deploy a light sail probe, a spacecraft powered by high-intensity laser beams from Earth. This innovative technology, similar to the Breakthrough Starshot initiative, would allow the probe to travel at nearly 20% the speed of light, reaching Proxima Centauri in just over 20 years. The probe, named Vanguard, was designed to carry a suite of advanced instruments capable of capturing high-resolution images, detecting radio signals, and even scanning for biosignatures. If an alien civilization truly existed on Proxima Centauri b, Vanguard would provide humanity's first direct look at another intelligent species. An unexpected signal. As preparations for Project Horizon continued, another breakthrough occurred. The Allen Telescope Array, one of SETI's most powerful radio observatories, detected a faint but structured radio signal coming from Proxima Centauri b. The signal repeated in precise intervals, an unmistakable pattern that could not be explained by natural astrophysical processes. The excitement was immediate. Unlike previous false alarms, this signal contained encoded information. Scientists scrambled to decode it, hoping to determine whether it was a message intended for Earth. Days passed as AI-assisted algorithms worked tirelessly to analyze the transmission. Then, at a press conference watched by millions worldwide, SETI researchers announced their findings. "This is unlike anything we've ever seen," said Dr. Elaine Foster, head of the SETI research team. "The signal is structured in a way that suggests intelligence. It follows mathematical sequences that appear universal, much like how humans might encode a first contact message." The world held its breath. If this was indeed an attempt at communication, what was it trying to say? Deciphering the message. The first breakthrough in decoding the signal came when researchers noticed repeating prime numbers embedded within the transmission, something that any mathematically advanced civilization might use as a universal language. Further analysis revealed patterns that resembled molecular diagrams, possibly describing elements or biological compounds. But then, something truly astonishing happened. The signal contained visual data, a form of pictographic encoding that suggested the senders were attempting to convey something more than just scientific information. When scientists reconstructed the images, they were left speechless. The first image appeared to depict a planetary landscape, complete with towering structures that resembled massive, interconnected domes. Another image showed what looked like anatomical sketches, possibly of the beings who had sent the signal. The implications were staggering. If this was truly a message from an alien civilization, they were not only aware of us, they were actively reaching out. A message from the stars. As the world debated the next steps, international space agencies convened an emergency summit. Should humanity respond? If so, how? Some scientists urged caution, warning that revealing our existence to an unknown civilization could be dangerous. Others argued that the opportunity to communicate with another intelligent species was too great to ignore. Meanwhile, deep within NASA's headquarters, a team of linguists, mathematicians, and AI specialists worked around the clock to construct a response. Using a combination of mathematical sequences, universal scientific concepts, and carefully chosen symbols, they crafted a message intended to bridge the gap between our species. The moment of transmission was met with both excitement and apprehension. As the encoded message was beamed toward Proxima Centauri b, humanity could only wait and wonder. Would they answer? The moment of truth. As humanity's carefully crafted response was transmitted toward Proxima Centauri b, the world held its breath. News channels ran continuous coverage, social media buzzed with speculation, and scientific communities debated the implications of direct contact with an alien civilization. Days passed. Then weeks. There was silence. Some skeptics began to suggest that the signal might have been a cosmic anomaly, a natural occurrence misinterpreted as intelligent communication. Others theorized that the aliens had received our message but were choosing not to respond. Then, on a quiet evening at the Allen Telescope Array, an unmistakable reply arrived. The alien response. The transmission came in a structured sequence, much like our own response. However, this time, the message was far more complex. As AI systems worked around the clock to decode the data, a pattern emerged. The message contained a visual representation of a star system, one that was immediately recognizable. It was not Proxima Centauri's system, but our own. The aliens were acknowledging that they knew of Earth. Then, something even more astonishing appeared in the data, a countdown. Preparing for contact. Panic and excitement spread in equal measure. What did the countdown mean? Were they coming to visit us? Was this a warning? A meeting request? Governments worldwide assembled emergency councils. Scientists, astronomers, and military strategists convened to discuss the possibilities. The countdown suggested an event would occur in exactly 2 years, an eerily specific time frame. Meanwhile, New observations of Proxima Centauri B revealed something shocking. The James Webb Space Telescope detected anomalous energy bursts emanating from the planet's surface, possibly signs of spacecraft launching. Humanity now faced the greatest moment in its history. We were no longer alone. The arrival. As the countdown reached its final weeks, all eyes turned toward the skies. Military forces stood on high alert, but most of the world watched with a mix of awe and anticipation. Then, on the exact day predicted by the countdown, they arrived. A fleet of unidentified spacecraft emerged from a distortion in space near the outer edge of our solar system. Unlike anything humans had ever conceived, the ships seemed to fold in and out of existence, shimmering against the backdrop of the cosmos. Radio telescopes picked up a repeating signal, an invitation. The aliens were requesting a meeting on the surface of Mars. A historic mission. NASA, ESA, and space agencies worldwide scrambled to assemble a delegation. The United Nations approved a mission, Project First Contact, to send representatives aboard an advanced SpaceX Starship toward Mars. On board were astronauts, scientists, and carefully chosen diplomats. The journey took months, but as they approached the designated meeting point, the alien ships became visible, immense, sleek structures hovering effortlessly above the Martian surface. Then, the moment everyone had been waiting for finally came. A shimmering light formed at the entrance of one of the alien ships, and they stepped forward. For the first time in human history, we stood face to face with an extraterrestrial intelligence. And they spoke. "We have been waiting for you."